down the rabbit hole we go. So a few days ago, I started the PCB for the forced air heating for the cold weather climate folk. And I really don't like the forced air stuff because you end up having to basically constantly heat air. And so it was really, really inefficient. It might have warmed the cabin, probably not much, but basically all that heat would have been lost just in the car body or whatever. So last night I kind of explored a concept that I've kind of mentioned a little bit in passing. It wasn't one of my original 4 ideas. What I've figured is that I can remove this bottom metal piece and replace it with a printed circuit board. There's a printout of that circuit board right there, and we'll look at it a little more in detail. But basically what you do is you remove the 12 bolts here, and then you don't even actually have to take these metal covers all the way off, which if you've done that, you know it's kind of annoying to get them back on. You literally just slide them out this way. You'll remove this guy right here, and then you will put the new PCB on. There's a specific way that it goes on, and then you will basically close this. And I actually got a thinner PCB than normal. Typically they're 0.0625, which is about 1.6 millimeters. But this one is actually 1 millimeter thick because that's what this is replacing. And this will actually detent on the edge stops there and there. And there's some guidelines or whatever. Now, one of the things I did is I had to figure out how much power we needed to put into this. And so I today basically mocked this up. This is an OEM IMA battery enclosure. And I've got it mostly together. I didn't have a fan shroud, but I just put some cardboard here. I figured it would kind of work about the same. And I put inside of here that same resistor I mentioned and showed the other day. And I just kind of put it in the middle to where it wasn't touching anything. And I started out at 50 watts of power total for the entire bay. And at 50 watts of power, I was able to increase about 20 degrees Celsius, which is pretty solid. And I said, okay, well, I'm going to design for 75 watts. I tried 75 watts out as well. And at 75 watts, I was able to get like, I think it was 35 degrees Celsius. So it could be negative 30 degrees Celsius and your battery would still be 5 degrees Celsius. Now there are a lot of assumptions and there's a lot of room for error here because 1, we don't have the thermal mass of the battery, whereas here we're just heating the air. 2, again, I don't have the fan shroud, which probably really isn't that important. Third thing is I don't actually have like the IMA built around this, so that might actually help us. Of course, it probably will hurt us because the IMA bay is all aluminum and pretty much all of it is going to be cold. Regardless, I think that 75 watts is going to be more than we need, and 50 watts will probably be a little bit less than we need. So what I did is I designed this for 75 watts. So let's look at the schematic, super simple schematic here. This is what we got. Pop these lights off. It's kind of dark. Let me, oh, you know what? I can just change the monitor brightness here. Okay, let's drop out of that. Okay. It's better. It'll be a little dark, fine. Literally just a bunch of resistors. I'm going to start with 2.2K resistors. These are 2010 resistors. In automotive land, you really don't want to go much larger than that because they tend to want to crack when you do like a 2512, for example. 2512 is probably like right at the limit. Regardless, these are 9S, and then there's just a bunch in parallel. There's 18 in parallel because there's 18 cells we're trying to warm on this one. And yeah, so we're dividing the entire pack voltage over 9 resistors. And you can see that graphically here on this screen, these 2 screens. I like portrait mode screens, but when you get to doing layout stuff, it's kind of odd. So yeah, we'll turn the silk screen off. The way you see this PCB when it's installed on the battery is it's just going to look like that. It's going to have these ground plane layers here and then some text basically, you know, to show you where the BMS connector is, you know, what it is this side away from cells, and then there's a hole you're going to center, etc. And there's actually some lines here that it says this line must be visible. This is just to help you install basically the circuit board. On the back here where the actual function is, these are all just the copper planes on the back. to spread this heat out. So at the end of the day, 75 watts over 48 cells is about 1.5 watts per cell that we're going to be throwing in through the bottom. And then of course we're dividing that 1.5 watts by 9. So I think it was 225 milliwatts per resistor. That's going to keep these resistors from getting too hot in any one localized spot. Obviously you don't want, you know, the battery to be burning on one side and freezing on the other. So anyway, there were a couple of issues here. There's some tabs on the battery here I had to do some weird heat spreading with, and then over here as well for a tab there. And then basically the 18S modules, they don't have any logic on them at all. They're literally just, you hook up the one of the high voltage leads here, and then essentially a switched version of the other one here. But it's not done on the 18S board. So the 18S board, I already ordered it. I just ordered 10 just so I can play around with them, and then, you know, it'll be me and I guess 4 people who really want this fast can get these units. So anyway, I ordered 10 of them. They should be here by the time I get back from Wisconsin end of next week. So early December, I should have these built up. Now the 12S is going to be similar, except that of course it'll only have 12 cells and not 18, so I'll get rid of 6 of these cells. And in their place, kind of dimensionally slightly different, I'm going to be doing the control logic circuit, which is actually very simple. It's literally just a FET. Let me turn this light back on here. It's literally just a high channel in FET. That's what it's going to look like there. It's going to have a photovoltaic isolator on it, which basically is a way that you can drive a gate with galvanic isolation. It's literally an LED and a solar panel, and the solar panel drives the gate when the LED is on. So anyway, that is going to be the 12S module, and I'll just put that there. And I will make sure that that works with both a 12S and a pseudo 12S module. So I'll probably end up on the 12S version. I haven't done the 12S yet. I ordered the 18S because that'll be here really soon, and I can basically just hook that up to a power supply here and power it and just see how well it heats up or not. And then the 12S one I'll order tomorrow. It'll be literally taking this board, cutting part of it off, and then making sure it fits properly, etc. That'll have the control logic, and it will switch as many boards in parallel as you want. It'll of course have a fuse on it as well, since it is going to be tied directly to the battery. As far as routing, I'm planning on having everything connect in the back here. For the 18S plus minus, because this cell is flipped around the other way, let me, well, you know, first we'll talk about the 18S minus. This is how the cells are in that, I believe. This one's flipped around the wrong way. This is the only one that matters here. Basically, the PCB will be in the battery here, and it will have, you know, the battery will be installed. It'll have 2 wires coming out of it, and then these wires, I didn't really prepare for this, sorry. These wires will be attached to this PCB, so when you get it from me, it will have 2 wires soldered in there. Boy. Anyway, these are going to have a screw terminal that goes over to the 12S, and of course they're going to have an outer insulating jacket, just like all the high voltage stuff does. And you'll basically come over here before you install this plate. You will screw these into the screw terminal on the 12S. So there'll be one there for this 18S module. There will be another one going into this 18S module here. And again, all 4 of these wires will have a secondary insulation layer, a conduit around them. Now, on the 18S minus configuration, the fan shroud here actually runs right up against this. You can see that right here. So the wires will be coming out of here, and then the fan shroud actually runs up against it. So we are going to have to probably cut this fan shroud a little bit on the inside, just some of the plastic. We won't be cutting the metal, probably just the plastic. If that doesn't work, another option could be to come through the side of this. On the 18S minus, we've already drilled the hole right here for the high voltage current cable to come through, and we could just drill another hole there if we needed to. That I'm kind of fudging it right now just because I know we'll come up with a solution. At the end of the day, this is how the 3 PCBs will be hooked together, and then to hook up to the actual Sorry, it's such a mess in here. I really need to clean. To hook up to the PCBs to the actual power, that will just come through these same holes here where we've already put other cables through, and we'll hook up to the negative here, and we'll hook up to the positive there. That positive has got quite a few connectors on it at this point. We might need to go to a longer M4 bolt there, but we'll see about that. I have a rough idea on all of this worked out. And again, so this will be basically 25 watts per PCB. It'll be slightly more. It'll be like 30 for the 18 here, 30 for the 18 here, and then, I don't know, 25, 20 here, whatever, 20 there. Probably 20 there, that would make more sense, yeah. Anyway, at that point, all we need to do is, I'm gonna start again trying to put about 75, maybe 80 watts in here. And then if that gets too hot, of course, we can just increase the resistor values. And at the end of the day, each one of these PCBs I build has 162 resistors on it. But it's all gonna be done with my pick and place, so, you know, go have fun. And these are super cheap resistors. They're like 4 or 5 cents a piece. That's actually pretty expensive for a resistor, but they're cheap enough. Anywho, that is the first proof of concept, maybe, for heating these modules. And again, the real big difference here from what I was proposing with this board is now we don't have to run these fans. So we literally can have all the fans off. And if we can get away with 50 or 75 watts, at 50 watts, we can run the packet, you know, assuming you turn the car off and it's at 75% state of charge, we can run that overnight. And then of course in the morning with the 5 amp hour G3, that will have consumed most of the power in the pattern, most of the energy in this pack or whatever. But before, the option was like, you know, if we do 300 watts in here, it's only gonna run for a couple hours. Now it can run for 8, assuming this works. And again, I do think the 75 watts is gonna be more than sufficient to keep these cells warm. In fact, I think if we push any more than that, we're going to start to get quite a heat gradient on these cells that we don't actually want. So anyway, we'll just play around with that. And of course, I have all these dead modules from Prototypist and I forget who else I have. I'm sorry, I'm bad with names. Anyway, so we'll be able to heat these up and then you know, heat them up overnight. So we'll leave them outside in the real cold for you know, overnight, and then in the morning we'll pull a module out and see what this heat gradient looks like. We don't want the heated side to be more than probably 30 degrees C, and we don't want the cooled side to be any more than, well, we want it to be above freezing, obviously, but we don't want a huge heat gradient. Ideally, this heat will spread through the cells pretty quickly, which it'll probably do because it has these aluminum outside walls, and the way the conductor in this pouch works, it should conduct pretty well. Anyway, we'll see how that goes. You know, we've got the one PCB ordered. We'll do the second one tomorrow, and then they'll all be back before Thanksgiving. And hopefully before then I clean up, because I am out of desk space pretty much everywhere right now. It's all full of heat solutions. Here's one idea I was looking at. I've got a lot of resistors pulled out right now, and heat sinks and other junk here too. You know, this type of device here. This is a PTC ceramic device that I thought would be really neat to do, but that, of course, was when we were going with the fan route. You know, we could have those sitting there, have 3 of those. Anyway, as always, thanks for watching.